Hello, everyone. Mike Mackay from DeSpray Environmental here with us today. Hello, Mike, and thank you for accepting our invitation.
Thank you. Yeah, hello everyone.
Mike, today we'll approach a topic that unfortunately it is not frequently enough addressed in the waste management industry, and that is aerosol can recycling. But before that, Mike, can you please tell us first a couple of things about yourself, your activity, and your experience in this field?
Yeah, sure. I come from a hydraulic background. I had 5 hydraulic companies, automated. We built automated machinery and electronic controls as well as hydraulic. Back in the late 90s, 1998 to be exact, we were approached by a company in the UK, a waste management company, because we made other machines for oil filters, recycling, and all kinds of recycling. And they asked us if we could do aerosols. Of course, we couldn't. Nobody could. But we took it on. And by the year 2000, 2001, we managed to create the very first 100% aerosol recycling machine. Of course, it took a couple of years to get it to work right, but by 2004, 2005, we had 4 or 5 completely reliable aerosol recycling machines. And when I say aerosol recycling, I'm talking about 100% recycling, not puncturing the can and squeezing it and getting metal. I'm talking the gas, the liquid, and the metals. So since then, to flash up to 2022, DeSpray, I'm the managing director of DeSpray. I've taken the position of technical sales and marketing now, and we're a Dutch-based company in the Netherlands, in Almelo, Netherlands, and we do all the engineering, manufacturing, and technical support from the Netherlands. So I'm in Canada with the customer relations and that sort of thing, and the other side is done in the Netherlands. So now we have our own recycling company as well, that we recycle our aerosols, a small little thing for testing, so we can prove out any different things that we run into. But that's where we are today, is trying to promote aerosol recycling as a mainstream versus a very unique, chic aerosol recycling, which it shouldn't be, in my opinion.
That is very, very interesting. Thank you very much, Mike. I think we can now jump into the situation. So my first question would be, first of all, are aerosol cans recyclable? And if yes, what is the status of the aerosol recycling industry in the Netherlands and in the EU maybe? What do you see as the main technical and legal challenges or opportunities from your side?
Right now, the aerosol recycling numbers are extremely low. From my perspective, if you are talking about 100% aerosol recycling, it's likely less than 5% recycled. And when I say that, I mean 100% recycled. There are areas, countries, cities that are recycling aerosol cans, but they're releasing the gas and the liquids to atmosphere. So things are changing very quickly. In the Netherlands in particular, we've worked pretty hard there. In the Netherlands, most of the aerosols were getting shipped out of the country to Germany in particular, and in England, to get recycled, because the problem with aerosols is they're explosive and they're hazardous waste. So it's not just the can. So that limits the customer. Even if you wanted to be a good citizen in Europe, and you wanted to recycle the aerosols, how do you do that? Where do you do that? And there's all kinds of legal implications and policies that kind of restrict that. I didn't answer all your question. So the issue with aerosols is every different country has different policies, and that's kind of changing now, where they're getting unified in Europe. And if you wanted to recycle, I'll just give you an example. If you can see this is a standard aerosol can. So old way of thinking is if I poke a hole in this can and release the contents to atmosphere and then squeeze the can into a metal brick, then I've recycled. Well, that's not even a half of the recycling, because the real damage is done with the gas. This represents the gas that we collect and recompress back to liquid fuel. And let's say the liquid itself, which is a hazardous waste. Because in the aerosols, there's not one kind of aerosol. You've got underarm deodorant, you've got hairspray, you've got bug spray, you've got brake cleaner, you've got foams, you've got gels, there's so many different things. It becomes one of the most complicated recycling things. So if it becomes the most complicated, then how is a standard recycling company, even if they wanted to do good, how are they supposed to deal with this? They've got 1,000, maybe even more different types of aerosols coming at them, and their job is, hey, the consumer wants them recycled, but it's not safe, because as I alluded to, you've got gas, which is explosive and fire, and you've got the liquid waste, and you've got the metal. And right now, that's kind of not being ignored, but I'd say put on the back burner, because nobody wants to face that reality. So there's 15 billion cans a year, aerosol cans, being produced. And we have if not the first, maybe there's only 2 technologies in the world that can recycle these. That's not very many. So because of that, then the percentage of recycling is way down. There are some initiatives going. UK's got an initiative going right now, a recycling initiative for aerosols. They've just started, and it's just started to be serious. Another thing that's happening right now is we're getting cooperation between the aerosol associations, the metal can industry or the aluminum industry, such as AluPro, and even Ball. Ball is the biggest can manufacturer in the world. So take one of those, the recycling guy, the waste management guy, the can guy, the whatever, and then us. There's a whole bunch of different balls up in the air, and so that this is pretty exciting. That this is starting to become united, and we're starting to work together. So as we speak, we've got collaboration with some of the aerosol associations, with the metal, the aluminum industry, and with the can manufacturer. So they realize if they want to get this can, I'm going to try to simplify this. If they want to get what everybody thought the proper recycling is, and I'm just going to hold one up. This is a metal brick. So this is a metal brick made from 200 aerosol cans. So in the past, this metal brick, if I made this, I was a hero because I'm recycling aerosols. Problem with that way of thinking is that's the small end of the problem. Yeah, it's great that we're recycling cans, but in order to get there, we've got to get the gas and we've got to get the liquids. That said, there's a whole bunch of, I think, false information out there with how much gas and how much liquid's in those cans. Why don't we just say for convenience that there's nothing in them? Well, that's total garbage, because there isn't nothing in them. And over 22 years, we've got proof that that's not true. So what is the number? And that number is important, because if you've got 0% gas and 0% hazardous waste, so you don't have a problem. You've just got a can problem, and you can crush those cans and you can make a recyclable product. But in reality, there's a post-consumer problem, or a post-consumer stream, sorry, and then you have an industrial stream, or let's say the fillers waste, so a commercial waste, and then you have the waste coming from the Walmarts and Costco's and the big box stores, and the end of life, shelf life, which is a bigger problem because they're all full. So you have a combination of full cans, semi-full cans, and in the post-consumer somewhere around 10 to 15% full, You add them all up and make a stream, you could have as high as 20-25% on average full of liquids and gas. And if I took this can right now and it's 25% full and lit it on fire, that's not cool. It's not to be ignored, but yet somehow it's being ignored. So sorry, I'm just kind of running on there, but I don't know if I answered that question completely. But one of the other issues with this is the post-consumer seems to get off scot-free. And when talking about policy, so I live in Ontario, Canada, completely different than our headquarters in Almelo in Netherlands, and completely different than the US. So I go to my local, we have what we call a stewardship. And I'm sure you have stewardships everywhere. But the stewardship, in order to work, has got to have enough money in the waste stream to pay the recycler or the city or the community or the waste management company. They've got to get paid for proper handling of the aerosol. And so I'm trying to explain to you how big of an issue that is. So if these waste management companies, these cities, even the aerosol fillers themselves, if they're going to do this, somehow there's got to be a fee attached to that can, and maybe an individual can, in order for those guys to get properly taken care of. So when I'm the consumer and I'm buying, this is a rust converter, and this is somewhere around the $9 Canadian dollars, $9 US, let's say, for that can. So now I spray it. This one's half full, and I'm done with my rust converter. I throw it in the trash. So that can is a big problem. And if I've got 15 billion of them, I got 15 billion problems. If I put a fee or a bounty on this can, sometimes that stewardship money goes into the wrong hands. So there's no doubt in my mind that there should be some sort of stewardship or some sort of fee for recycling, whether it's hidden in the base price or not, but it's where that money goes that's important. And I'll give you an example. If I'm a local recycling company, and our technology is not cheap, and it shouldn't be cheap because you don't want to blow things up and have fires and kill people. So there's so much safety initiatives in our system, it can't be cheap. It's not a compactor, because that would be easy. Compact, release everything to atmosphere, don't care about fires, put them out, and get the metal. But so now let's say it's an expensive piece of equipment, which it is. It's a world-leading technology. So if I'm a recycler, so here comes the problem. I'm getting to where the problem is. And I say, yeah, okay, I've got enough, or a city, it doesn't matter if it's a recycler, or a city, or whoever, and I've got enough interest that all my people want to do good. No doubt about it. So they want me to do this. So I'm going to pay $500,000, $1 million to buy technology. I've got to get permitting, which is super tough to get. So I got to get permitting to put this recycling system in, and I've got to make a specialty building. I've got to buy the thing. I've got to set it up. It takes me a year to do. I've got manpower involved. I've got whatever. Just for argument's sake, I paid $1 million. Here lies the problem. So I put $1 million in. I can buy a compactor for $50,000, not $1 million. So, but if I put it through the compactor, everything's going to atmosphere. I've got fires, I've got hazards, I've got potential explosions. I've got a whole bunch of problems in safety. And here lies the problem. The best way, or not the best way, the easiest way to solve that problem is to landfill the bloody things. So just landfill them. So even if I collect them in my blue box, and now they go to wherever that is, the secret place that collects all these blue boxes, what do? The consumer at my house thinks I've done the right thing. I put it in my blue box. It gets to think they don't have the technology, they don't have the safe technology, they don't have the methods, they don't have anything to recycle that properly. There really is only one place to put, well, there's two places to put it. One would be take your chances in a standard compactor and crush it with Coca-Cola cans and hope nobody sees it and it doesn't catch on fire, which it will eventually, or landfill it. So that's the recycling rate on aerosols is so low because of those reasons, not because people don't want to do the right thing. It's not because the communities don't want to do the right thing. It's not because the recycler doesn't do one thing. But if you put, I'm going to go back to the stewardship. Let's say I put 50 cents on a can. Right now, in most cases, there's nothing. So you're going to try to get your return on investment on metal. Well, that's pretty hard to do. In Coke cans, yeah, it's easy to do. I can do 10 million Coke cans. I've got so much weight for metal. I've got a $50,000 baler or maybe a $100,000 baler. I pay for it in a year and everybody's happy. But that's not the case for aerosols. So if you put, right now, there's not an initiative to pay for the recycling on the can. So the fillers, they don't want the consumer to see that you're paying a 25-cent or a 50-cent hit on a can, because that's going to bring down sales. But that doesn't necessarily have to be on the can. You don't see a Coca-Cola can with 10 cents on it, or a wine bottle with 20 cents on it. By the way, there is a 20-cent fee on wine bottles in my territory, but zero on aerosols. How can that be? Like a wine bottle, yeah, a wine bottle or a Coca-Cola can or a beer can. Beer cans have 10 cents here, 10 cents. If I had 10 cents times 15 billion cans, that's a lot of money for the recyclers. But 10 cents seems a little bit ridiculous. Maybe it should be higher. In my opinion, it should be, because I'm dealing with these gases. So yeah, there's a lot of problems there. Not that they're unsolvable, and I see a very positive future on things. It might take 5 or 10 years to get there, but there's acknowledgement now. And where even 3-4 years ago, even for the Aerosol Association to be green, they wanted to have their plants be 100% green. So, but what did that? The things that went around that is that, okay, so I drive a Tesla to the filler plant. I've changed all my light bulbs to LED. I make sure nothing goes out the back door, no cardboard, no cans, no soda cans, no whatever. So my plant is green, so to speak. So yeah, that's great. So the initiatives is that we have this green initiative in the plants, but once the 15 billion cans go out the back door, that's forgotten about. So that's a big problem. So the plant's clean, yeah, no doubt about it. They've done a great job on their initiatives, but it's follow that to end of life. And if you followed an aerosol can to end of life, you're going to see a lot of ways that gets discarded and not handled properly. Because first of all, it probably can't be handled properly in most regions because they don't have the equipment, and secondly, they don't have the initiatives to pay. Like, let's face it, if you got paid properly you're going to recycle it, and it's a niche market, it's an exclusive market. So there's the positive side. If you can get the policies and the money stream changed to deal with this, and the entrepreneurs and the recycling companies and the cities, if they can make money on it, of course they're going to go for it. So what I'm kind of getting at is it's follow the money, and if there's no money in it, it's going to landfill. So
yeah, thank you, Mike. These are some unbelievable insights that you have just told us. But speaking of all these different stakeholders that you mentioned, why is it so necessary for people to really understand the importance of aerosol recycling? I mean, how much damage can it really do to the environment if it's not recycled properly?
Well, that's a good question. So I got to be careful the numbers I use, but I've been doing this for 22 years, and the numbers are staggering. So if you've got, just go with the 15 billion. So if you go with 15 billion, I think it's actually rising closer to 16 billion cans filled a year in the world. So each one of those, just take an example. If you've got a 400 or 500 milliliter can, and 10% of that is on average 10%, and now I'm using numbers that are vague, but on average, if 10% of 15 billion cans is exposed to atmosphere, that's a big problem. And you say, well, it's not 10%, it's 2%. 2% is not correct. Almost never correct. So if you got 15 billion times, I'm using 10%, that's a low number, by the way, then you've got a number equivalent to, I'll just give you some numbers, 450 million cubic meters, or 450,000 cubic meters of hazardous waste going to atmosphere, 450 million. So when you compare that to, like, if that's hazardous waste in a liquid form, an oil spill that big would be, like, the Deep Horizon was 780 million. That went on for 8 months, leaking, freaked out the whole world. So we've got more than half of that at 10%, which is low, in aerosols every year. But it seems to be missed and it seems to be lost. So to answer your question, that's polluting the environment, whether it's ground pollution in the landfill. And let's take the landfill. Now I put that can in the landfill and times 15 billion. What happens to it? Eventually it breaks down. So this can will break down and rot and whatever and break, and then the gases are released to atmosphere, and the liquid is polluting the ground. Has to be. And as well as that is you're missing the opportunity for the recycling of the metal itself and the liquid and the gas. So if we take that liquid and we capture the liquid, that can be used for completely for waste energy. So why should that be landfill? Completely. So it's a low grade fuel. Even when you mix it with all the other products, it becomes a low grade fuel. The cement industry loves it because they get it for cheap or free, or the customer even pays for it in some cases, and they get a low grade fuel. Waste energy, not the absolute ideal condition, but that works. The gas itself is almost as high quality as propane. So now you've got the gas you're collecting for waste energy, but the problem in Europe in particular is you can't use waste gas to recycle. You can't use it. So now our customer buys the equipment, they get this gas. What do they do with the gas? This is great gas. We have engines running off it 24 hours a day. You can run it to heat buildings. It's that good. So if you're not doing that, then that's a greenhouse gas. That's global warming. It's contributing big to global warming. So yeah, sorry. Did that answer your question?
Yeah, exactly. I mean, it summed up pretty well the problem with the problem that are doing the damage that these aerosols are doing to the environment. And in this regard, Mike, I wanted to go further and ask you a little bit about the DeSpray recycling technology, how it works, who is addressed to, maybe some technical insights.
Okay, I could share my screen, would do it better, but
yes.
Yeah, can I share my screen?
Yes, please, of course.
Okay. Okay, can you see my screen?
Not yet.
Okay, one sec.
Yeah, okay, I'm seeing it now.
You see now, let me get rid of you. Let me get rid of some of this stuff. I have some stuff in the background here. Okay, so to answer your question, if you can see that.
Yes.
I'll get rid
perfectly.
of
Okay. Nice picture of your colleagues.
Okay, okay. Yeah, it shouldn't have the colleagues, but this this system here. So what we do is we build a complete aerosol recycling factory. That looks like a blue box. It's a 20-foot sea container. Yes, that's one of the most complicated pieces of equipment you'll ever see. Inside that box, that's got to be safe. We're dealing with all the things I just told you about. Inside, we have oxygen detecting. We've got air exchange. We've got VOC detection. And we got blowout panels. We got blowout discs. Everything is involved there. So in this 20-foot sea container, we build this in Elmo. This is what DeSpray does. This is the most advanced technology in the world for aerosol recycling. So we build that, we test it in Elmo as a completely operational factory. And And when it's done and tested in Elmelo, then we take all the outside pieces off, ship it. This one is in the USA. We ship it to site. In a week, that's reinstalled, reassembled, and you have a fully operational factory. And then we follow it with training and whatever. How it works, this just looks like a box. If I can follow my crosshairs here.
Yes, we can see.
Let's say you put this yellow thing here. There's 2 wheelie bins. Each wheelie bin might have 500 cans in it. So for argument's sake, 1,000 cans go into that. The guy pushes a button. Everything's completely automated. It's a 1-person operation, not 6 as you see here. Maybe 1 for sorting, so you're not throwing things undesirables in. Push a button, everything happens automatically. And then I'm going to show you how that happens if we got the time. Do we have the time?
Yes, of course, Mike.
Okay, so I just wanted to show some major things. We got a lift here. We got an upper hopper here. We got a PLC screen here, which we can monitor from anywhere in the world. We can see how this machine is operating. Temperature, pressures, flow rates, everything. We can change those parameters. We can troubleshoot. So it's a really high-tech piece of equipment. On this end of it, we got a standard IBC. That IBC collects all the liquids that are commingled with. Usually, we don't sort these cans other than taking the undesirables out. So all the mixed product goes together in this IBC. In this IBC, we degas that liquid so it can travel properly. And that is usually when it's full. We have laser control on it, so we know when it's full, fully automated. And that will go to the cement kilns for waste energy. And then this yellow container you see here, that's the magic and the secret. So as I'm going to change screens here. I'm going to change that. Can you see that?
Yes, perfectly.
Okay. So this is the basic dumbed down version cartoon of how this machine works. So on this side here, that lifter goes in, it dumps 2 cans of aerosols. Just for argument's sake, let's say there's 1,000 cans to dump. So the lid opens, these cans fall into the machine, the lid closes. So it's a batch, has to be a batch. You can't shred these things, you can't do them because you're introducing oxygen into an explosive gas. So this hopper closes. Inside the hopper, we have sensors that says, hey, there's too much oxygen. So it will introduce nitrogen until this chamber, this crushing chamber, is inert and is safe. So it's fully automatic. So if it's not down under, let's say, 4%, the machine won't work. So then nitrogen keeps getting introduced here till it's a safe atmosphere, and then the machine starts crushing those cans. And all 1,000 cans, the machine won't stop until they're all done. And inside there, as I showed you brick earlier, it makes brick after brick after brick. They stay inside the machine. As they're being crushed into bricks, the liquid obviously falls out with gravity, and the gases also come out inside the chamber. So it's all enclosed. So we suck the gases out of the chamber. We separate the gases from the liquid under vacuum. So we get the suspended gases out of the liquid. And then we recompress that gas back to the liquid fuel. That's what the yellow tank was. So we're recompressing this back to liquid propane, basically. So it almost has the same properties. Depending on what the mixture is, there's different gases and aerosols. But that liquid gas is very high grade fuel. And there's quite a bit of it. So we ourselves are involved with one of our customers in the US and our own setup where we're running engines, and we're getting, one case we're getting, I think, 70 kilowatt hours out of that fuel. And in some states, some provinces, some countries, this is the problem. They won't allow this gas to be used as a recyclable product for waste energy. So that's one of the hurdles. That gas can be used, which we run ourselves, and we know it can, for an engine. And it can all be used for heat. And we all know what the price of gases are nowadays. So
Yeah.
this is about 4 times better than it was 6 months ago. But yeah, it all sounds great, but some of those barriers have to be knocked down in order to recycle that properly. And here's the crazy part. If you're not doing this, so you're not allowed to do this, but I'm allowed to take 15 billion cans and crush them and let it just go to atmosphere. You're allowed to do that, but you're not allowed to do it for waste energy. Not in all places, but in Europe in particular, it's a tough go. And then all the liquids get the IBC. It's standard industry IBC, and that's degassed, and that goes to the cement kiln. So that's how it works in a nutshell. Hope I didn't go too fast. Sorry, I missed the other end. So as that gets the liquid and gas go to the other end. When the process is all done, the lid opens automatically and kicks out 4 or 5 bricks into a bin, and then you've got your high grade metal for recycling. So yeah, that's it.
Yeah, excellent. That's very nice interactive presentation, Mike. Maybe just a follow-up question on how does your technology contribute to all these waste to energy efforts and landfill diversion? How should a municipality or a waste management company choose an aerosol can recycling system? So are there any specific criteria for this, or do they need some highly qualified personnel for this thing? Or
usually we walk them hand in hand. A lot of the companies that are dealing with this are hazardous waste handlers, but that it has become more mainstream with standard recycling companies, let's say a municipality, whatever. We would have to do training with them, or they'd have to collaborate. Probably better solution would be to collaborate with a waste management company that are used to handling different products. This is a specialty product, so they'd have to have some training in it, but we could do that with them. And it's like, so if you have this in your blue box and it goes to your municipality's MRF, what do they do with it? They don't know what to do with it. So it depends on how big the community is, but perhaps they could partner with a waste management company that could take from different communities. That makes the most sense. We are making a small system. We're calling it our micro. We're building it right now. After 22 years, I think that's the legacy of the aerosol industry. We've got big systems. Sorry for rambling on here, but our biggest system can do maybe 10,000 cans an hour. That's a lot, and capturing the gas and whatever. But that's targeted at a big waste management company that has streams from everywhere. So now we've gone down to a machine. That machine you saw there can do at least the small. There's all different versions, but let's say 2 million cans or 2,000 cans an hour.
It's pretty impressive.
Yeah. So right now, the future is our micro system will do 500 cans an hour, and that system is the footprint's maybe 4 meters by 4 meters. That's it. Completely turnkey, 4 meters by 4 meters. You can do 400 or 500 cans an hour. But when you use those numbers, who's paying for those 400 or 500 to pay for the machine? That's where the disconnect is. So is that at a stewardship? Is that in a bounty per can? Is that and maybe that's where it's got to go. So,
Thank you, Mike. One more question. I promise I won't torture you anymore.
Yeah. No, I'm enjoying it.
I want to talk a little bit about the future, and wanted to ask you, how do you see the aerosol spray recycling industry in the coming years? And more importantly, how do you see the spray role in this equation, and maybe the plans to remain the global leader, something that would need to be improved maybe?
Yeah. Well, how do I see it? I would say in the last couple of years, things have changed huge, because the ignorance or the lack of wanting to address this waste stream, which I tried to show you guys is a big problem, was completely ignored or wanted to be ignored because nobody really had a solution. But what's happening right now is that if you look at the World Aerosol magazine, I just wrote an article in here last month, In the same magazine, not my article, is an article from the Can Manufacturers Association, CMI, and the very top headline is Aerosol Recycling Initiative Launched. That's in the UK. We're working with them. DeSpray are working with AluPro, the CMI, and Balkans, and to work together as a team, and that's where I see the future. It's in the aluminum can industry's best interest to recycle aluminum. Look at the energy prices right now to make aluminum. Just in the last year, it's changed the whole ballgame. To get the gas to fill these, there's a lot of gas. So they got to buy this gas. If we can use this gas for waste to energy, it just seems ridiculous not to. Where DeSpray is going with our initiatives is we're hoping to work with these associations, with these communities, whatever, and try to unite them so that it's a united front that's multiple. You need the recyclers in this. You need the waste management companies in this. You need the governments in this to recognize this as a product, and that's something that I didn't touch on. So the aerosols are not recognized as a waste stream. So how do you judge how good you're doing in aerosols? Anywhere. It's not in Canada, where I'm from. Aerosols are not recognized as a waste stream, therefore they don't exist. And I think that's almost everywhere. If they were recognized as the waste stream, then you can, it doesn't matter how bad it is, the recycling rate, then you've got a marker, you've got a point to start. And we all know that they're not being recycled in general properly, otherwise they'd need to use our technology. But bad enough, okay, but we're all in this together. And if we say, okay, so here's our marker, but you can't have that marker if they're not recognized. You're recognizing that the factory that filled them is 100% clean, but you're not recognizing that 15 billion went out the back door and they're not being recycled. So that stream needs to be recognized as a standalone stream. Same as aluminum can, same as paper, same as cardboard, same as anything. And once you have that, then changes will be made. So I'm hoping that I'm getting a little bit long in the tooth and old. I'm hoping that in the next 5 years, and I can already see it just with that initiative that you're seeing, that there's a collaboration to, first of all, recognize aerosols as a waste stream, and it's a big one. And not in my backyard, it has to be in my front yard. And if we can collaborate and recognize it and have these different associations work together to solve the problem, aerosols aren't going away. I don't want them to go away. They're so convenient. They're so whatever. The world, there's 15 million. You're not going to stop that. But what we can do is have an initiative to collaborate so that these things are recognized and get recycled for waste energy. And if you're not doing waste energy with them, then it's going to atmosphere.
Exactly. Yeah.
Yeah.
So we can sum up and say that at the minute there is a lot of progress in the aerosol recycling industry, but at the same time there is a lot of space for improvement in the next couple of years.
Yeah, there is, and I think it's exciting that there's that collaboration is actually happening. It's been a long time, but late is better than never.
Better than ever, exactly.
Yeah.
Mike, so, thank you very much. If you have anything to add for our audience or any final thoughts, if not, I am very happy and we are very happy that you were here with us today. And I just want to take the opportunity and thank you for all the information provided. And we are really looking forward to having you in our future waste-related events.
Thank you. I'll just put it out there for your audience. I'm available. I'm considered an expert in aerosol recycling. There's not too many of us, so that's
like you.
Yeah, so I'm self-appointed expert. So if anybody needs any help or anything like that, I can do specifically for health and safety and the engineering side of things for their companies, whether they're waste management or municipalities or whatever. Look me up on DeSpray. I'm on LinkedIn as well, and I'd be happy to help you out.
Thank you very much, Mike.
Okay, thank you.
Thank you. Thank you.
Bye-bye.
Bye-bye.